All right, so we're going to go factoring, specifically by decomposition, which is one of many styles of factoring. We factor when we're in standard form. So this is considered the original standard form of a quadratic, okay? And I guess we should write that out. This is our standard. And the reason we factor is to get into what's called factored form. Okay? And factored form, I'm actually going to move this question, the one we're about to factor below, just so you can see what factored form looks like. Factored form is written as y is equal to a bracket x minus r, x minus s. All right, those in minus r minus s. So we move from standard to factored form through the process of factoring. That's what that is. And decomposition is one of those styles. And there's, like we said, many different styles. In order to do decomposition, we have to recognize our standard form, which we have here, and we have to be able to tell which coefficients and constants are our A, B, and C. Okay, so in our question, which is the A coefficient?
2.
Yeah, 2. What is the B coefficient?
Negative 22.
Yeah, negative 22 by default makes this C, right? Okay. In decomposition, we're looking for sets of numbers, in fact, factors. We're looking for two numbers that multiply to our A term times our C term. Here. And those same two factors are going to add to our B term. Okay? Now, I should say, technically, the very first step to factoring is to common factor, and I could common factor out the number 2, but it's not necessarily the first thing you have to do. It can be something we do at the end. So we're going to focus on the factoring, and then we'll talk about if we common factored first, and we'll do it at the end, how it would have changed things, but you still end up essentially at the same place. So I need to set this up. So I need two numbers that multiply 2. And this is where common factoring comes in handy if you do it beforehand, because it kind of reduces this number we're looking with. But 8 times C in this case is 2 times 56, which is 112. So two numbers that equal 112. That can be a hard one to find factors for. Those same two numbers, I guess we're right in blue, need to add up to our B term, which is negative 22. So there's negative 22 difference between these. So we're going to fire out a bunch of factors by trial and error and try to figure out which ones. Where's my calculator? There it is. Which ones work? So 112. Oh, let's see what goes into that. Maybe does 11 go in? No. 112 does 8 go in? 14. Yeah, 8 goes in with 14. Ooh, I got really lucky on that one. Okay, so for instance, I could have said 2 went in. Okay, and it would have been 2 times 56, but I know 2 plus 56 doesn't give me where I want to be. And this is interesting, this negative term here. Okay, what that means is one of our factors, at least one, maybe both, need to be negative. By looking at our last term, and this is what kind of tells us how many of these terms will be positive or negative, because it's a positive, that means I either have 2 positive numbers that multiply to this, or I have 2 negative numbers that multiply to this. Okay. Since this is going to be negative, that means I'm probably working with pairs of negative numbers. Okay? And luckily, by kind of going through the process, I discovered, well, 8 times 14 gets us here. 8 plus positive 14 doesn't get us to negative 22, but negative 8 times negative 14 does. Okay? And negative 8 times negative 14 is positive 112. So those are my 2 terms. Those are very important for what we're going to do. So my next step will be to rewrite the equation, okay? 2a squared, and usually we write this with x, but a is fine, it's just a variable, plus 56, okay? We are then going to split this middle term, and this is the idea of decomposition. We're splitting this, and we're going to split it into y equals, the rest of the stuff gets rewritten, 2a squared, and I can put these in any order I want, negative 8a, and negative 14a, and that's where we split the 2, plus 56. And I'm going to show you what that idea is. It's the same concept of, let's say I had the number 9. Well, I can actually write 9 if I want as 5 plus 4. They're the same thing. I've decomposed it. Okay, I split it up. And that's what we did here. Negative 22a can actually be negative 8a minus 14a. We've decomposed the middle part of this. So from there, we have to know some common factoring. And essentially what we do is we do some common factoring is this first pair we common factor and our second pair we kind of common factor here. Okay, and actually I want to write this a little differently with brackets. I like it with like this thing because it'll be simpler to make out what I'm doing here. And these two. Okay. So in our first set, I need a common factor of the first two terms. What goes into both coefficients? Can you think of a number that goes evenly into both of these?
2.
2. 2 definitely goes in. Great. And in fact, because there's an a in both, I can divide by 2a. Okay. And that's actually going to be really common practice when you're doing this. The first set of terms, you're usually going to be able to take out the exponent if you've set it up in this process. Okay. So when I go to write this, I write 2a on the outside, and then in brackets, what would be left? Well, the 2's cancel out, and a squared divided by a is just the number, or the variable a. Negative 8a divided by 2a, well, negative 8 divided by 2 is negative 4, and the a's cancel out, so that's all that's left in the bracket. That's the first set. The second set, what would be a common factor of these terms here? Okay. I think it's going to be the number 14. Let's test it out. 56 divide 14. 4. Great. And that's a great number to pull out. Now, I'm going to give you a word of advice. Because this is negative, we usually want the first term in this bracket, and that'll be the first term in the next bracket we make, to be positive. So we're actually going to common factor out the negative with it. We'll always get into that habit. Okay. So we're going to divide both of these by negative 14. Which means this negative 14 comes out here. And in our bracket, well, negative 14 divided negative 14 is positive 1. And the a stays. I could write 1a, or I could just write a. Positive 56 divided negative 14 is going to be negative, and I did it on the calculator, it's 4. And this is actually what you're trying to do. If you notice, these two brackets are the same. Okay. Now I can show you a common factoring reason that this works, but essentially the next step is those two brackets can be just written as one bracket, and I'll quickly go over it again. A minus 4, okay, so those two brackets are the same, so we write them as 1. And our other bracket is just what was left over, so that's the 2a in the front and the negative 14 here. Okay. Now, to explain what the heck went from this step to this step, how did that happen? Well, I want you to think of it this. I'm going to say let x equal a minus 4. Okay, so when I go to rewrite this, it now says y equals 2ax minus 14x. What is a common factor of both those terms right now?
X.
X. So I divide x out of both. So then it becomes y equals x 2a minus 14. Okay? And notice that that's this bracket here. But x isn't just x. X is what we said here. So it's actually y equals a minus 4 when I replace it. 2a minus 14. And that's how we got our final answer. Okay? You don't have to do these steps every time. Just realize that those two brackets are the same. Therefore, I can just kind of put it to the front. So I rewrite it all in black at the end. Y equals a minus 4, 2a minus 14. Now, I said I wanted to talk about common factoring. Technically, this is a legit answer. This is fine. I could have, like we said, factored out 2 at the very beginning. If I look in the brackets, I can common factor 2 out of one of the brackets. Which one?
The 2a
Yeah,
minus 14.
exactly. So I can do it at the end if I really want. I can common factor out 2. You don't have to. This is still an acceptable answer. But if I common factor 2 out of here, and I can write the 2 in the very front, because that's usually what we do with our constant term. I'll write 2. So we divide both of these by 2, we'll say. And we have a minus 4, and this becomes a minus 7. These two are technically the exact same thing. I've just factored this fully. That's what they call that, being factored fully. And that's why they usually common factor first. But doing at the end is not a problem.